Hello! Hope you had a wonderful time learning from home. Today we are going to learn about chemical formulas. To do that, we must first memorize the various ions and their charges. First, group 1 metals all carry a charge of +1. So lithium ion has a charge of +1. The symbol is Li+. Sodium has a charge of 1, Na+. Potassium has a charge of 1, and K+. So all group 1 metals ions have a charge of +1. Group 2 metals will all have a charge of +2 because they have 2 valence electrons. They give up the 2 valence electrons, so they have 2 less electrons. 2 less electrons is equivalent to 2 more positive charges, so they all have a charge of +2. So magnesium is Mg2+, calcium is Ca2+, and barium is Ba2+. Similarly, metals in group 3 have 3 valence electrons. They will lose those 3 valence electrons, so they will end up having 3 less electrons. So 3 less electrons is equivalent to having 3 extra positive charges, so they all carry a charge of +3. In group 3, the common metal you have to remember is aluminium 3+. Now we move on to the non-metal side. For the non-metal side, let's start with group 7, which are the halogens. The halogens have 7 valence electrons, so they just need one more electron to achieve the stable octet configuration. When they receive that one extra electron, they would have a -1 charge. So therefore, the fluoride ion is F-, the chloride ion is Cl-, the bromide ion is Br-, and the iodide ion is I-. Let's move on to group 6. Group 6 elements have 6 valence electrons. They are short of 2 electrons to achieve the stable octet noble configuration. So they will all strive to receive the extra 2 electrons. When they receive 2 more electrons, they end up gaining 2 negative charge. And hence, group 6 elements, when they form ions, the ions carry a charge of 2-. So in the case of oxide, the ion is O2-. In the case of sulfide, the ion is S2-. Let's move on to group 5. Now group 5 has 5 valence electrons. Group 5 elements have 5 valence electrons. They need 3 more electrons to achieve the stable noble octet configuration. So when they receive 3 extra electrons, they gain 3 negative charge. So the nitride ion is N3-, the phosphide ion is P3-. These are the ions whose charge can be worked out by virtue of knowing its group number. But there are transition metal ions whose charges cannot be worked out from the periodic table because they belong to the transition metal block which lies between group 2 and group 3. So they do not have a group number because they do not have a definite charge. So we just remember the common charges of these ions. For lead, the common charge of the lead ion is Pb2+. For zinc, the common charge is also 2+, so zinc is Zn2+, Zn2+. Copper commonly also has a charge of 2+, so copper ion is Cu2+. And iron can have 2+ charge or 3+ charge, so we have iron 2+, Fe2+, or iron 3+, Fe3+. Finally, silver is Ag+. Let's now move on to the polyatomic ions. These are usually non-metallic ions. First example is the ammonium ion. We have to remember ammonium ion as being NH4+. Next, we have to remember the nitrate ion as being NO3-. Then we've got to remember the carbonate ion as being CO3 2-. And we must remember the sulfate ion as being SO4 2-. And finally, we have to remember the hydroxide ion as being OH-. These have to be committed to memory before we are able to proceed to the next stage of the learning. Hi, let us now work out the chemical formula for sodium carbonate. First, sodium is in group 1, so the charge of sodium ion is +1. The carbonate ion, you can only recall from memory, it's CO3 2-. It's important to realize that an ionic compound has overall no charge, so it is electrically neutral in total, which means the amount of positive charges is equals to the amount of negative charges. Now here in this situation we have +1 and 2-. They are obviously not balanced. The charges are not balanced. The positive charges do not balance the negative charges. What is the easiest way to balance the positive and negative charges? Well, we simply multiply the positive charge by 2 and we will end up with 2+, and 2+ balances 2-. So that is what we need. 2 sodium ions match to 1 carbonate ion. So the chemical formula for sodium carbonate is Na2CO3. Hi, let us now work out the chemical formula for aluminium sulfate. First, recall that aluminium is in group 3, so the aluminium ion is Al3+. The sulfate ion is SO4 2-. Again, the overall chemical has to be electrically neutral, so the total number of positive charges must balance the total number of negative charges. What is the easiest way to achieve balance between the positive and the negative? In other words, what's the easiest way to balance 3+ with 2-? Answer is lowest common multiple. The lowest common multiple between 3 and 2 is 6. So 2 times 3+ gives you 6+, whereas 3 times 2- gives you 6-. 6+ balances 6-, which means we need to have 2 aluminum ions and we need to have 3 sulfate ions. Hence, aluminum sulfate is Al2, and then you have altogether 3 sulfates. That is the chemical formula for aluminum sulfate.